What are solar storms? Are they deadly? How do these powerful outbursts from the sun impact Earth and other celestial objects in our solar system? Could they disrupt our modern technology or even threaten future space missions? In this video, we'll dive deep into the world of solar storms. We'll explore their origins, their surprising impacts on our daily lives, and we'll visualize the May 2024 solar storms using real data from NASA, the National Aeronautics and Space Administration. By the end, you'll understand how these fiery phenomena can shape the future of human exploration in space. The Sun, our very own star, isn't just a giant ball of gas providing warmth. It's a nuclear fusion powerhouse constantly bombarding space with energy and particles. This stream of particles and radiation creates what we call space weather, and it can have dramatic effects across the solar system. Solar events happen when the sun's magnetic fields become tangled and suddenly release energy. These can take the form of solar flares, intense bursts of radiation, or coronal mass ejections, CMEs, which are massive clouds of plasma and magnetic fields ejected from the sun's corona. When these reach Earth, they can cause geomagnetic storms that disrupt everything from GPS satellites to electrical grids. But not all solar storms are the same. Scientists classify the intensity of these events using scales like the X-class for solar flares and the G-scale for geomagnetic storms. Let's break it down. Solar flares are ranked in classes, with X-class being the most powerful. These flares can trigger significant radiation storms, with X10 flares or higher being especially intense. The numbers following the X-class indicate how strong they are. For example, an X2 flare is twice as intense as an X1 flare. Geomagnetic storms, on the other hand, are rated on the G-scale from G1 to G5. A G1 storm is relatively minor and might cause weak power grid fluctuations or some impact on satellite operations. But a G5 storm, the strongest on the scale, can cause widespread disruptions to electrical grids, satellite failures, and even visible auroras much farther from the poles than usual. Earth is shielded by its magnetic field, which deflects much of the sun's harmful radiation. However, during powerful solar storms, some particles slip through and disrupt our technology. This is why we have satellites like NASA's Solar Dynamics Observatory, SDO, constantly watching the sun for signs of danger. On the moon, though, astronauts wouldn't have such protection. With no atmosphere or magnetic field, solar radiation could be deadly, requiring habitats or suits with heavy shielding. Meanwhile, on Mars, with only a thin atmosphere and no global magnetic field, solar radiation is a major threat to future colonists. During a strong solar event, they could face harmful radiation exposure that penetrates the Martian surface. The May 2024 solar storms were some of the most significant solar events in recent years, classified as G5 class geomagnetic storms. These storms were triggered by a highly active region on the Sun, AR 3664, which erupted with multiple coronal mass ejections from May 8th to May 15th. The storm peaked on May 11th when a massive CME reached Earth, resulting in significant geomagnetic disturbances. The storms disrupted Earth's magnetic field, making it one of the strongest since the Halloween storms of 2003. This geomagnetic storm caused severe disruptions to GPS systems, satellite communications, and even power grids. Satellites like GOE-16 experienced temporary data losses, and space-based internet providers like Starlink saw performance degradation. Even high-frequency radio communications and drones were affected by the storm. However, the storm was somewhat of a windy storm with little rain, as the high-energy particle output was less intense than expected. Still, auroras lit up the skies far beyond their usual range, treating viewers in parts of Europe and the northern United States to spectacular light shows. It's important to remember that the sun's activity follows a roughly 11-year cycle, known as the solar cycle. During a solar maximum, solar storms and flares are more frequent and intense, while during a solar minimum, the sun is relatively calm. The May 2024 solar storm occurred during a period of increasing solar activity as we approach the next solar maximum. But don't worry, while solar storms can cause disruptions, they're not going to destroy civilization. Thanks to our understanding of solar activity, we're learning how to shield both our technology and future explorers as we prepare for missions to Mars and beyond. Even spacecraft in deep space are designed to withstand these solar outbursts. Understanding space weather is crucial for our technology and future space exploration. The SDO's data helps us understand these events better, allowing us to predict and mitigate their impacts on our technology and daily lives. By studying these solar events, we can better prepare for their impacts and protect our planet and beyond. Thanks for joining us on this cosmic journey. Stay curious and keep looking up at the stars.